The universe is silent. Not the silence humans know on Earth, but a kind of silence that feels infinite, ancient, and unbroken. Out in the darkness, far beyond the soft blue glow of our planet, space stretches in every direction for billions of light years. It is a place where stars are born and destroyed, where planets drift like small islands in a black ocean, and where mysteries wait with no hurry at all. For thousands of years, humanity has looked up at this endless night and asked the same question: are we alone? No answer ever came. No sign, no message, no visitor, only silence. But in the late 1970s, something changed. NASA scientists, driven by curiosity and courage, began to imagine a mission unlike anything ever attempted before. A plan to send an artificial messenger out of the solar system into the great unknown. And with that plan, a new chapter in the story of humanity quietly began. The narrator speaks softly as a camera moves across the calm night sky, showing stars scattered like frozen sparks. He explains how everything started with a simple idea: if humanity cannot travel across the galaxy, then a small machine will go in our place. This is where the story of the Voyager missions begins. It is 1977. The world is very different. Smartphones, internet, and modern computers do not exist. NASA scientists sit in crowded rooms filled with paper maps, manual calculators, and giant machines with blinking lights. The technology looks old by modern standards, but the dream behind it is enormous. The Voyager spacecraft, 2 identical probes, are being prepared inside NASA Jet Propulsion Laboratory. Engineers check wires, tighten metal frames, and test antennas. They know that once these probes are launched, they will never return. They will travel farther than any object made by humans in history. The narrator explains how the mission was born at the perfect moment in time. The giant planets, Jupiter, Saturn, Uranus, and Neptune, were lining up on one side of the Sun in a rare alignment that happens only once every 176 years. This alignment would allow a spacecraft to use gravity like a slingshot, moving from one planet to the next using almost no fuel. If NASA missed this window, it would not come again for generations. The mission could not fail. It was humanity's one chance to explore the outer solar system directly. Scientists worked day and night. Every bolt was checked. Every circuit was tested. Some engineers slept inside the building because going home felt like wasting precious time. They knew they were building something more than a machine. They were building a message of hope, a voice that would speak for all life on Earth long after its creators were gone. The narrator describes the atmosphere inside the laboratory. There is excitement, but also tension. Voyager is designed to last only 5 years, just long enough to fly past Jupiter and Saturn. No one is sure if it will survive the cold, the radiation belts, or the long journey. Some scientists believe the probe might shut down before it even reaches Jupiter. Others whisper that Voyager might continue working for decades, but nobody knows the truth. The documentary camera slowly zooms across the golden surface of the famous Golden Record, the disk that will carry humanity's message to the stars. It rests inside a protective aluminum cover, mounted on the side of the spacecraft. The record shines softly under the lab lights, like a small sun. This record contains pictures, sounds, and music from Earth. The greetings of 55 languages, the heartbeat of a young woman, classical music, traditional songs, the laughter of a baby, the simple sound of rain, all chosen with the hope that if an intelligent species finds Voyager one day, they will understand that humans once lived on a small blue planet and wanted to reach out into the universe. Carl Sagan and his team selected every item on the record with care and emotion. The narrator explains how Sagan believed that even if the Golden Record never reached aliens, it would still be a symbol, a reminder of humanity's optimism during a time filled with fear and global tension. Near the spacecraft, scientists perform final checks. The launch date is close. Workers secure cables on the launch pad. The Voyager probe rests inside the rocket, waiting like a sleeping traveler. The camera cuts to the sky above Cape Canaveral. The morning is quiet. The air feels heavy with expectation. Families gather outside the launch site, their children holding binoculars. Reporters set up microphones. NASA teams sit in control rooms, their eyes fixed on monitors. A voice begins a countdown. 10, 9, 8, the engines ignite. A tower of fire grows beneath the rocket. 7, 6, 5, the ground shakes. 4, 3, 2, a deep roar fills the air. 1, we have liftoff. The rocket rises into the sky like a spear of brilliant fire. People cheer, but many only watch in silence, understanding the importance of this moment. Voyager is no longer just a machine. It has become humanity's first true explorer of the unknown. Far above Earth, Voyager separates from the rocket and continues its journey. Its antenna unfolds like a metallic flower. Its instruments wake up one by one. Its camera takes the first pictures of Earth, a tiny crescent of blue and white against the blackness of space. The narrator explains how this image shocked scientists. For the first time, humanity saw itself the way an alien might see it, small, fragile, beautiful. As Voyager moves past the moon's orbit, Earth becomes smaller and smaller until it is only a pale speck of light. Then the spacecraft continues onward, crossing the orbits of Mars and the asteroid belt. Radiation hits its body. Dust particles bounce off its metal shell. Yet the probe remains steady, following its programmed path, sending signals back to Earth. It is here that the suspense quietly begins. Months pass. Voyager travels deeper into space, farther than any human-made object has ever gone. Its instruments begin detecting strange radio waves, signals that scientists do not immediately understand. These signals are not messages from aliens. They are natural cosmic phenomena, but they sound unusual, rhythmic, almost like a pattern. In NASA control room, the data creates excitement. Some engineers wonder if they are hearing something never detected before. This marks the beginning of a question that will grow throughout the entire mission. Is something out there? Of course, the documentary narrator makes clear that no evidence of aliens has been found, but the mystery of the universe remains alive. The narrator shifts to the emotional side of the story. He describes how the Voyager spacecraft slowly becomes more than a scientific device. It turns into a symbol of humanity's desire to explore, a tiny metal traveler carrying our dreams across the darkness. As it approaches Jupiter, the camera shows swirling storms on the gas giant, lightning flashes deep inside the clouds, and moons orbiting like silent guardians. The audience gets a taste of the discoveries that lie ahead, but part 1 ends before those discoveries are revealed. Instead, the narrator brings the audience back to a final, haunting image: Voyager drifting through space, small and alone, swallowed by infinite night. He says softly, "In the long quiet of space, Voyager travels onward. It does not slow down. It does not turn back. It carries a golden message across billions of miles, moving into places where no life from Earth has ever been. It is a question sent into the darkness, waiting for the universe to answer." The suspense is left hanging. Something awaits Voyager in the next stage of its journey, something giant, powerful, and full of secrets. And so, the first chapter of NASA's search for aliens closes, leaving the audience eager for more. The story now moves back in time, long before Voyager touched the darkness of deep space, long before the spacecraft saw Jupiter's storms or crossed the invisible borders of the solar system. It returns to the moment when the dream first began, inside NASA-busy laboratories, where hundreds of men and women were trying to build something the world had never seen before. The narrator's voice becomes calm and steady, like a teacher guiding the audience into a memory. He explains that in the early 1970s, NASA engineers faced a huge challenge. How do you build a machine that can survive a journey of billions of miles? How do you prepare a spacecraft to travel through radiation belts, deadly magnetic fields, freezing temperatures, and storms on planets bigger than 1,000 Earths? And how do you do it with technology far weaker than what exists today? Inside the Jet Propulsion Laboratory, JPL, hallways echo with the sound of footsteps, ringing telephones, and urgent conversations. Engineers wear thick glasses, carry stacks of paper, and draw diagrams on chalkboards. Nothing about this mission is easy. The narrator highlights a simple but powerful truth: the Voyager spacecraft is being built for a journey no human has ever attempted. If it fails, there is no backup plan, no rescue team, no second chance. NASA scientists gather in conference rooms filled with maps of the solar system. On the walls, large posters show Jupiter, Saturn, Uranus, and Neptune, still mysterious worlds in the 1970s. Back then, no spacecraft had ever visited these planets directly. What little humanity knew came from blurry telescope images. The scientists talk for hours, debating designs, testing ideas, and solving problems that seem impossible. One engineer asks, "What if the radiation around Jupiter fries our electronics?" Another replies, "Then we build shielding." But shielding adds weight. Then we reduce weight somewhere else. Every decision is a balance between risk and hope. The narrator explains how Voyager must be small enough to carry on a rocket, but strong enough to survive for years, maybe decades. It must be intelligent enough to operate on its own, yet simple enough to run on a computer weaker than a modern digital watch. Still, the engineers do not give up. In another part of the laboratory, technicians assemble Voyager's heart, the computer. It is made of thin wires, golden circuits, and tiny logic boards. Compared to modern devices, it looks ancient, almost delicate. But to the engineers, it is a masterpiece, a computer that can store commands, correct mistakes, and protect itself from cosmic radiation. The narrator focuses on a moment when the computer team tests a simulation. They run a program that makes Voyager think on its own. The room fills with excitement as the computer successfully executes commands. It is a small victory, but an important one. If Voyager cannot think independently, it will not survive the journey. The camera shows close-ups of workers tightening screws, checking fuel lines, and attaching instruments. Each instrument has a purpose. A magnetometer to read magnetic fields, a plasma detector to measure charged particles, cameras to take photographs of planets, a radio system to send signals back to Earth. Together, these instruments give Voyager a new identity, not just a machine, but a scientist. Now the narrator shifts toward one of the most emotional parts of the Voyager story, the creation of the golden record. It begins with a single idea proposed by a small group of scientists. If Voyager is leaving the solar system forever, it should carry something from Earth, something that tells the universe who we are. Carl Sagan, a gentle and visionary astronomer, is chosen to lead the project. He gathers writers, artists, linguists, and thinkers. Their job is to select the messages that will represent humanity. The narrator describes the room where the Golden Record team meets. There is excitement, but also pressure. They have only weeks to choose the sounds and images that will represent every human culture, every continent, every part of Earth's history. What should be included? A child laughing, waves hitting the beach, the sound of a heartbeat, pictures of animals, plants, cities, and what about music? Should they add classical music, jazz, tribal songs, folk music from distant cultures? In the middle of these discussions, Carl Sagan makes a powerful statement. This record is a gift, not just from one country, but from the entire planet. The narrator explains that every sound chosen for the record carries meaning. The sound of rain represents nature. Beethoven represents human creativity. Greetings in 55 languages show unity. A mother's kiss, a baby's cry, and even the sound of footsteps show that humans feel emotions and live full lives. For a moment, the documentary slows down. The camera moves across the surface of the golden record, capturing its warm golden glow. It becomes clear. The record is not just a message. It is a time capsule, a memory of Earth as it was in the late 20th century. With the record finished and the spacecraft almost complete, NASA faces another major challenge: testing. The narrator describes how Voyager is placed inside huge environmental chambers, metal rooms that can simulate the freezing cold of space, the vacuum, and the heat of the sun. Engineers watch through thick windows as Voyager is blasted with vibrations, radiation, and shock waves. If the spacecraft breaks now, it can be fixed. If it breaks in space, the mission fails forever. The tests are brutal. At one point, a sensor malfunctions. At another, a camera fails to calibrate. Teams rush to solve each problem, working long hours with determination. One engineer marks a note in his journal: "We are building for the unknown. That is the hardest part." Then comes the moment everyone has been waiting for. Voyager is declared ready. Its body shines like polished metal. Its instruments are armed. Its antenna is strong. Its golden record is locked in place. But before launch day arrives, something unexpected happens. NASA discovers they can program Voyager to do more than originally planned. The narrator explains how the mission suddenly expands. Instead of simply flying past Jupiter and Saturn, scientists realize Voyager might have enough power to continue toward Uranus and Neptune, and beyond them into interstellar space. This discovery fills the laboratory with excitement. It means Voyager could become the first spacecraft to leave the solar system, a traveler into the galaxy. The engineers consider what this means. They realize that Voyager might outlive them. It might still be traveling billions of years after the last human on Earth has taken their final breath. This thought humbles everyone. Yet even with these dreams, the risks remain. No one is sure if Voyager will survive the first years. Many believe it will last 5 years at best, but hope pushes the team forward. The scene shifts to the launch site weeks before liftoff. Technicians carefully lift Voyager into the rocket's upper stage. Workers tighten clamps, attach wires, and double-check every bolt. The spacecraft looks small inside the massive rocket, almost fragile. The narrator describes how people felt during these final days. There is pride, fear, excitement, and uncertainty. Some engineers stand quietly, watching Voyager being prepared. Others take photographs, knowing they may never see the spacecraft again. The night before launch, a storm rolls over Cape Canaveral. Lightning brightens the sky. The ocean wind howls. Some engineers worry the weather will delay the mission. But by morning, the storm fades and the sky is clear. Launch day arrives. The narrator transports the audience to the final moments before liftoff. Inside NASA control room, dozens of people sit at their stations. Screens flash with numbers. Radios crackle with updates. Outside, the Voyager spacecraft waits inside the rocket, still, silent, ready. A voice begins the countdown. T-minus 20 seconds, the engines warm, the ground shakes. Control room lights shimmer as vibrations grow. 5, 4, 3. The flame ignites. A blast of fire shoots downward. 2, 1. Liftoff. The rocket rises into the sky. A trail of smoke follows. Voices cheer. Some scientists cry. The Voyager mission is officially on its way. The narrator concludes the part with a powerful cinematic line. On this day, humanity sent not just a machine, but a message, a hope, a dream, a small traveler carrying the story of Earth toward the unknown, toward the stars. Space grows darker. The sun becomes smaller, a faint golden dot shining far behind Voyager 1 and Voyager 2. Silence around the spacecraft is deeper now, so deep that even radio waves seem to travel slowly. But ahead, hidden in the darkness, waits the first destination of the Voyager missions, Jupiter, the king of planets, a world so giant that more than 300 Earths could fit inside it. The narrator sets the tone. Voyager is no longer simply a machine drifting through space. It is about to become humanity's eye, our first window into worlds never seen up close. As Voyager approaches Jupiter, its instruments wake up. Cameras rotate, spectrometers activate, sensors begin measuring magnetic fields and temperatures. The documentary camera follows the spacecraft as it glides like a tiny metal bird, heading toward the largest storm in the solar system, the Great Red Spot. A storm bigger than Earth, a storm that has been raging for centuries. The narrator explains how, in the 1970s, humans knew very little about Jupiter. Most images from Earth's telescopes were blurry, unclear, and lacking detail. Some scientists believed Jupiter was a giant ball of gas with simple clouds and nothing more. Voyager was about to change everything. The spacecraft sends its first close-up images to Earth. Inside NASA control room, scientists and engineers gather around monitors. What they see takes their breath away. Jupiter's clouds are not simple. They are layered like giant waves of cream and fire. Swirling patterns stretch across thousands of kilometers. There are brown belts, white zones, and storms shaped like spirals and ovals. The planet looks alive, moving, shifting, roaring with energy. The narrator describes how the Great Red Spot appears on Voyager's camera. It is not just a spot, it is a rotating hurricane of crimson clouds. Lightning flashes deep inside it. Scientists stare, amazed. For hundreds of years, astronomers had seen this spot from Earth, but no one understood its true scale until Voyager captured it in detail. The Great Red Spot is violent, monstrous, a storm so large that it could swallow Earth without slowing down. But Jupiter is not the only wonder Voyager discovers. Voyager turns its cameras toward the planet's moons, 4 giant satellites that orbit like mysterious kingdoms. The first is Io, a moon unlike anything humans expected. While Voyager flies close, something unexpected appears on one of the images, a strange mountain, then a bright plume, then an eruption. The narrator's voice becomes dramatic. Voyager has discovered active volcanoes on Io. This changes everything. Until this moment, scientists believed that Earth was the only volcanic world in the solar system, but Io is alive with fire. Its surface erupts with fountains of molten lava that rise higher than Mount Everest. The moon is covered in yellow, orange, and red sulfur plains, colors that look like a painter spilled his brightest pigments across a frozen world. Scientists in the control room cheer. This is one of the greatest discoveries in the history of space exploration. Next, Voyager approaches Europa, a moon that looks calm, smooth, and pale. At first glance, it appears simple, just a white sphere. But as images sharpen, something mysterious reveals itself. Europa is covered in cracks. Long lines stretch across its surface like scars on a pearl. The narrator explains what scientists begin to suspect. These cracks are not from ice breaking randomly. They are formed by something pushing upward, something moving, something warm beneath the surface. For the first time, humanity receives strong evidence of a subsurface ocean, an ocean hidden under Europa's icy shell. If liquid water exists there, could life exist too? The narrator does not claim answers, but the question floats quietly in the minds of the audience. Voyager continues to explore Jupiter's neighborhood. Ganymede, the largest moon in the solar system, is revealed to be bigger than Mercury. Callisto appears ancient, covered in craters older than any mountain on Earth. Each image Voyager sends changes scientific textbooks. Each discovery raises new questions. Documentary shows scientists comparing data, pointing at screens, and debating theories with excitement glowing in their eyes. Jupiter, once a distant giant, has become a living world of storms and moons full of surprises. But Voyager's journey is far from over. The narrator transitions with a slow, cinematic zoom-out. As Voyager leaves Jupiter behind, it heads toward another world, cooler, calmer, but hiding secrets of its own. The next destination is Saturn, most elegant planet in the solar system. As Voyager gets closer, its cameras capture something breathtaking, massive rings made of ice, dust, and broken moon pieces. They circle Saturn like a glowing halo. From Earth, Saturn's rings always looked simple, thin, and smooth. But Voyager reveals a shocking truth: the rings are not solid. They are made of billions of tiny ice particles, each reflecting sunlight. Some are the size of mountains. Others are as small as grains of sand. The narrator describes the beauty of Saturn through Voyager's perspective: golden bands, shadowed rings, curved lines of frozen light. It is like watching a cosmic painting in motion. NASA scientists stare at the images in awe. Voyager's discoveries reveal that the rings have divisions, waves, and mysterious dark gaps caused by unseen moons. This is not just a ring system, it is a complex, dynamic structure sculpted by gravity and chaos. Voyager then turns toward Titan, Saturn's largest moon. Titan is different from any moon Voyager has seen so far. It has a thick orange atmosphere, so thick that the surface cannot be seen through the haze. The camera shows a glowing sphere hidden beneath layers of smog. The narrator explains how strange this is. No other moon in the solar system has such an atmosphere. Titan's air is full of methane and nitrogen, the same nitrogen found in Earth's atmosphere. Scientists begin to wonder, could Titan have liquid lakes, rivers, maybe even the chemical building blocks of life? Voyager cannot see through the haze, but its instruments detect something exciting. Titan's atmosphere is rich in organic molecules, molecules that form the foundation of biology. Although Voyager cannot land there, it leaves the world with a powerful mystery. Titan will remain a place of curiosity for decades until future missions return. After Titan, Voyager flies past several smaller moons. Some are cracked like Europa, others are smooth like polished stones. One moon, Hyperion, looks like a sponge floating in space. Each moon adds another piece to the cosmic puzzle. As Voyager prepares to leave Saturn and head toward Uranus, the narrator slows the pace. He describes a moment scientists will never forget: the family portrait. At Saturn's distance, Voyager turns its camera back toward the solar system. The planets become small dots of light. Among them is Earth, a tiny blue spark shining alone in the darkness. Although the famous pale blue dot photo will come later, this early glimpse already carries deep emotional weight. Humanity sees itself again, not as separate nations or individuals, but as one fragile world floating in a vast, cold universe. The narrator reminds the audience Voyager is now far beyond the safe reach of Earth. If anything breaks, it cannot be repaired. Yet the spacecraft continues, fearless and steady, flying toward planets no spacecraft has ever visited. The scene transitions to a dramatic shot of Voyager drifting through the shadows of Saturn's rings, illuminated by the faint sunlight. The sun is now a distant star, small, pale, and slowly fading behind Voyager. The warmth that once guided the spacecraft is disappearing. The familiar planets are gone. Even the powerful pull of Jupiter and Saturn has weakened. Voyager enters a region of space no human spacecraft has ever reached, the outer edge of the solar system, a place where sunlight struggles to travel, where darkness becomes thicker, and where the rules of space begin to change. The narrator's voice becomes slow and deep, setting a tone of mystery. He explains that this part of the solar system is not empty. It is filled with charged particles, magnetic fields, and streams of energy flowing outward from the sun, rivers of invisible radiation called the solar wind. Voyager's instruments detect these winds weakening, becoming thinner and colder. The spacecraft is approaching a cosmic border that separates the sun's protective bubble from the rest of the galaxy. This border has a name whispered like a legend among scientists: the heliopause. It is the doorway to interstellar space. But crossing it will not be easy. The narrator brings the audience into NASA control room. Decades have passed since Voyager launched. Many of the original scientists have retired. Some are no longer alive. But new generations of scientists sit at the computers now, men and women who grew up reading about Voyager's discoveries, now watching over the same spacecraft they admired as children. Voyager still sends data, but slowly. Its power is weaker. Its instruments are aging. Every bit of information that reaches Earth travels for more than 17 hours before arriving. Yet the spacecraft continues faithfully, like an old traveler determined to finish the final chapter of its mission. Suddenly, unusual patterns appear in the data. The solar wind readings are changing in ways the team has never seen. The magnetic field seems stronger, almost distorted. Scientists lean closer to their screens. Something strange is happening. The narrator explains that the outer solar system is a chaotic zone. The boundary between the sun's influence and interstellar space is not a clean line. It is a stormy region filled with waves of pressure, collisions of particles, and sudden bursts of energy. Voyager, small and fragile, enters this turbulent zone. The The spacecraft shakes slightly as it travels through shocks of charged particles, silent storms that can stretch millions of kilometers wide. Voyager is designed to survive harsh environments, but no one knows if it can endure this. The narrator builds suspense. Voyager is now flying through a region no instrument has ever measured. Every reading is a mystery. Every moment is a risk. As days turn into weeks, the data grows more intense. Cosmic rays, high-energy particles from outside the solar system, begin to increase. This is the first sign that Voyager is nearing the heliopause. The spacecraft is leaving the safety of the sun's bubble. One morning, NASA scientists gather around a monitor that shows a dramatic change. The solar wind pressure has dropped to almost zero. A silence fills the room. This can only mean one thing: Voyager is standing at the doorstep of interstellar space. The narrator paints the moment with emotion. A spacecraft built in the 1970s, using technology weaker than a calculator, has reached the very edge of the solar system more than 35 years later. It is one of the greatest achievements in the history of exploration, but the crossing itself is still ahead, and the universe is not done testing Voyager. As the spacecraft drifts toward the heliopause, radio signals become distorted. For the first time, communication feels uncertain. Magnetic field outside the solar system presses against the sun's magnetic field like two invisible forces wrestling in slow motion. Voyager, caught between them, continues forward. The narrator describes the heliopause like a cosmic ocean shoreline. On one side is the warm water of the sun's influence. On the other is the cold, deep ocean of the galaxy. Voyager is crossing from one world into another. Inside NASA, scientists hold their breath as new data arrives. The magnetic field direction suddenly changes. The solar particles drop completely. Cosmic rays spike to record levels. A scientist whispers, "This is it, this is interstellar space." But nothing is confirmed yet. They need more readings, more time. Voyager continues. Outside the solar system, the environment becomes darker and colder. The narrator explains that even starlight is weak here. The nearest stars are light years away. There is no warmth, no sound, and almost no particles. Space is emptier than anywhere Voyager has ever traveled. Yet, ironically, it is also more active. Cosmic rays fly through this region like invisible arrows. Dust from ancient supernovas floats quietly. Whispers of energy from distant galaxies drift like faint echoes. Voyager's instruments detect low-frequency vibrations, strange radio waves that ripple through the interstellar medium. These are not alien signals. They are natural hums of the galaxy itself. But they sound eerie, mysterious, almost like deep breathing. The narrator describes the sound NASA generates from the data, a ghostly, rising tone that feels ancient. It is the voice of space, real, powerful, and unforgettable. In the control room, the final confirmation arrives. On a quiet afternoon, a chart spikes upward. Cosmic ray intensity has reached patterns that can only exist outside the solar system. Scientist finally declares, Voyager 1 has crossed the heliopause. A wave of emotion fills the room. People clap, some cry, some simply sit in silence, overwhelmed by the meaning of the moment. The narrator's voice softens. With this crossing, humanity becomes an interstellar species, not by our bodies, but through a small machine that carries our curiosity. Voyager is now in interstellar space. No spacecraft has ever traveled farther. But the story is not over. Voyager continues sending back information about the interstellar medium, the density of particles, the strength of magnetic fields, the flow of galactic radiation. Each reading teaches scientists about regions of the universe never studied before. The narrator shows the spacecraft drifting through endless darkness. Its golden antenna glows faintly. Its metal body reflects the dim starlight. Behind Voyager, the sun shines as a tiny star, smaller than a grain of sand. Ahead lies the Milky Way, an ocean of stars stretching across eternity. The narrator shifts to a philosophical tone. He explains that Voyager's journey is more than science. It is a reflection of humanity's deepest desire to explore, to learn, to push beyond boundaries that seem impossible. Voyager cannot land anywhere. It cannot meet aliens. It cannot return home. But its presence in interstellar space is a message that humans are explorers by nature, always reaching beyond what they know. The spacecraft will continue traveling for tens of thousands of years, long after it stops sending signals, long after Earth itself changes, long after the civilizations that built it are forgotten. Yet Voyager will still be there, a silent traveler carrying the golden record, waiting for someone somewhere who might understand it. The camera opens on a silent, endless darkness, deeper and colder than anything Voyager has ever passed. Stars glow like tiny diamonds scattered in a black sea. Nebula clouds drift slowly, their shapes stretching across millions of miles. The galaxy watches quietly, and somewhere within this cosmic silence floats a small, aging traveler, Voyager. The narrator's voice enters gently, almost whispering. Far from home, beyond the reach of the sun, Voyager drifts alone. It has no destination. It has no map. It follows a path shaped only by gravity, time, and the dreams of those who built it. Voyager's golden antenna reflects faint starlight. Its instruments, though old, continue sending soft pulses of data back to Earth, whispers from the edge of the galaxy. But this is no longer only a scientific mission. Voyager now carries something deeper, a question for the universe. A question humanity has asked for thousands of years: is anyone out there? And if someone is, will they ever hear us? The narrator guides the viewers back to Earth, not the modern world, but the Earth of the late 1970s when Voyager was first launched. The world was full of hope and fear, peace and conflict, dreams and uncertainty. Humans were taking their first steps beyond the moon. They knew they might never travel to distant stars themselves, but a small machine could. This desire to be heard by the cosmos gave birth to the Golden Record. The documentary camera drifts close to the golden disc mounted on Voyager's side. Its surface glows softly like a memory frozen in metal. The narrator explains its meaning. The Golden Record is a message in a cosmic bottle. It carries the voices of children, the sound of wind, the rhythm of music, and the heartbeat of a young woman. It carries greetings in 55 languages and images of life on Earth. Not perfect life, but life full of hope. If an alien civilization finds Voyager, they will hear greetings like, "Hello from the children of planet Earth." They will see pictures of mountains, forests, animals, cities, and people of all cultures. They will hear laughter. They will hear the ocean. It is a portrait of humanity, honest, emotional, and fragile. The narrator reminds the audience, no one knows if the record will ever be found. The universe is enormous. Stars are separated by distances that light itself takes years to cross. Yet Voyager carries the message anyway, because hope travels farther than spacecraft. Voyager now moves through interstellar space, a place filled with remnants of ancient stars, dust from supernova explosions, energetic particles drifting since before the Earth even formed. This region is quiet but powerful. The narrator explains how scientists on Earth still listen for Voyager's signal with massive antennas. Each ping of data is weaker than the last. It is like hearing a whisper from across the ocean. Yet even after 40 years, Voyager continues to speak. Inside NASA Deep Space Network, scientists compare old readings with new ones. They track tiny changes in magnetic fields, measure cosmic rays, and study vibrations carried through interstellar plasma. Every bit of information Voyager sends is priceless. There is no other spacecraft out here. Voyager is the only human-made object exploring this part of the galaxy. The narrator shifts the tone, becoming more philosophical. He describes how Voyager's journey mirrors humanity itself, a story of courage, curiosity, and survival. Voyager should have stopped working decades ago, yet it continues. Its power fades, its instruments struggle, and its systems age, but it refuses to fall silent. The spacecraft has already exceeded its expected lifetime many times over. Its radioisotope battery, once full of energy, now fades slowly each year. Soon, engineers must make difficult decisions, which instruments to keep alive and which to shut down forever. In meetings, NASA teams discuss how to preserve Voyager's last remaining functions. They know that one day, the spacecraft will no longer have enough power to speak. Its voice will fade into the static of space. The narrator describes this moment with emotion. When Voyager's final signal leaves its antenna, it will travel into the darkness for billions of years. Even after Earth changes, even after the sun burns out, Voyager's last whisper may still exist, moving silently between the stars. The documentary now explores the big question: will aliens ever find Voyager? The narrator does not offer fantasy or fiction. He presents the scientific reality, beautiful, hopeful, but honest. He explains that the galaxy contains billions of stars, and many of those stars have planets. Some planets may have oceans, atmospheres, or temperatures similar to Earth. Some may carry life, simple or intelligent. Voyager will pass by many stars in the next million years. None are close enough for an intentional meeting. But the possibility remains. If a star system has a civilization capable of interstellar travel or long-range scanning, they might detect the probe. They might examine the Golden Record. They might hear the sounds of Earth. The narrator imagines the moment gently. A distant species, older and wiser than humans, discovers a small metal traveler floating in the dark. They touch the Golden Record. They play its sounds. They hear Earth's music and wonder who created it. But the narrator also reminds the audience, even if no one finds it, the message still matters. It was never only for aliens. It was also for us, for humanity, to declare that we existed and we cared to be heard. The scene shifts back to Voyager drifting in interstellar space. Its small thrusters occasionally fire, correcting its position. Its antenna remains pointed toward Earth. It travels at more than 17 kilometers per second, fast enough to circle Earth in 25 minutes. But to the galaxy, it is slow. A leaf floating in an endless cosmic river, yet its journey is not measured in speed. It is measured in meaning. Voyager is humanity's first long-term ambassador to the stars. The narrator explains, long after human languages change, long after cities rise and fall, long after continents shift, Voyager will continue on. It will drift through the galaxy for billions of years, long after the memories of those who built it are gone. In this way, Voyager is immortal. The documentary shifts to a powerful emotional theme. What will aliens think if they find the golden record? Will they understand the greetings? Will they understand music? Will they recognize mathematical diagrams? Will a mother's kiss recorded on the disc carry any meaning to them? Will they see Earth as peaceful or dangerous or hopeful? The narrator reflects, humans place the best of themselves on the golden record. Not war, not conflict, not fear, but kindness, beauty, and dreams. If aliens hear it, they will hear not just who humans were, but who humans wanted to be. Voyager becomes more than a mission, it becomes a promise. As the documentary approaches its final moments, the narrator brings everything together with calm, cinematic energy. Earth appears again. Far behind Voyager, just a tiny dot in the distance, a lonely world shining in the dark. Carl Sagan's famous sentiment echoes softly, we are a way for the universe to know itself. Voyager carries that truth with it. The narrator describes the final future of the spacecraft. One day the last instrument will shut down, the last battery will lose power, the antenna will go silent, but Voyager will keep traveling, silent, alone, eternal. It will drift past new stars, new worlds, new cosmic events. It may pass planets that no human will ever see. It may cross through nebula clouds glowing with newborn stars. It may pass civilizations that have risen and vanished before its arrival. And perhaps, just perhaps, someone will find it. Someone will play the golden record. Someone will hear Earth's voice. The final shot shows Voyager floating among distant stars. The narrator ends with a powerful closing line. Voyager carries no weapons, no threats, no demands, only a message of curiosity, peace, and hope. In the endless silence between the stars, it waits, a small traveler asking a timeless question, is anyone out there? And whether the universe answers or not, Voyager will keep carrying our story forever. A soft echo of radio signals fills the air.